Hi, welcome to Lecture 17, a short lecture on percent composition. So there are two types of ways to look at weight. There's formula weight, which is the sum of atomic weights of each atom in its chemical formula. For example, if we look at sulfuric acid, the atomic weight of hydrogen is 1, but we have 2 of them. The atomic weight of sulfur is 32, we have 1 of them. And the atomic weight of oxygen is 16, and we have 4 of them. So we sum up the individual atomic weights of each atom times how many atoms are in the molecule, or the formula, I should say, and we end up with 98.1 atomic mass units. Molecular weight, on the other hand, is the sum of the atomic weights of each atom in its molecular formula. So if we look at the molecular weight of glucose, we have 6 times the atomic weight of carbon, which is 12, plus 12 hydrogens, which have the atomic weight of 1, plus 6 oxygens, which have the atomic weight of 16, which equals 18 atomic mass units. Now, if the chemical formula is that of the molecule, the formula weight equals the molecular weight. From my experience, generally that's the case. So they are interchangeable for the most part. So we'll calculate the formula weight of calcium nitrate, CaNO3 We have one calcium atom. The atomic weight of it is 40.1. So the atomic mass units is 40.1. If we look at the nitrogen, we have 2 nitrogen atoms. So it's 2 times 14 atomic mass units, which is 28. And we have 6 oxygen atoms, because 3 times 2 is 6, times the atomic mass of oxygen, which is 16, which equals 96 atomic mass units. We then add up 40.1 plus 28 plus 96, and we get a formula weight of 164.1 atomic mass units. We do get the atomic mass units from the periodic table, so you just look those up from the table. So to calculate the percent composition, we take the percent of the element, which equals the number of atoms of that element times the atomic weight of the element divided by the formula weight of the compound times 100%. So if we look at C12H22O11, the formula weight is 342 atomic mass units. We get that using the stuff on the previous slide. Now, if we want to know how much carbon is in this molecule, we take 12, because there are 12 carbons, times 12 atomic mass units, because that's the atomic mass of carbon, divided by the total formula weight, which is 342 times 100, or we get the percent carbon as 42.1%. If we look at the hydrogens, we have 22 hydrogens. The atomic mass of hydrogen is 1, and we divide that by the formula weight of 342 times 100, we get 6.4%. And finally, we look at oxygen, and we have 11 oxygens times the atomic mass units of 16 divided by the formula weight of 342 times 100 equals 51.5. A good way to check this is if you add up 42.1 plus 6.4 plus 51.5, you get 100%. So it's as simple as that. So let's look at some examples. Sulfur dioxide, the formula weight is 64.07. We have 1 sulfur atom. So if we take that 32.07 divided by 64.07 times 100, we end up with 50.1%. We look at the oxygens. We've got 2 oxygens. The atomic mass of oxygen is 16. 2 times 16 divided by the formula weight of 64.07 times 100% equals 49.9%. Again, 50.1 plus 49.9 equals 100. So that's good. Let's look at another example. Here we have sodium sulfate, atomic mass unit of 142.07. We take 2 times 22.99 divided by 142.07 times 100, and we get 32.4%. We look at the sulfurs. We have 1 sulfur. Sulfur times the atomic weight of sulfur, 32.07, divided by the formula weight of 142.04 times 100 equals 22.6%. And we look at oxygen. We have 4 oxygens, 4 times 16 atomic mass units divided by 142.04 atomic weight, or formula weight, times 100% equals 45%. Again, we add this up and we get 100. 32.4 plus 22.6 plus 45 is 100. Another example, we look at methyl acetate. The formula weight is 74.08. We have 3 carbons. We have 6 hydrogens and we have 2 oxygens. We times those by the atomic mass units and divide them by the formula weight. And we end up with 48.6 plus 8.1 plus 43.2. This comes to 99.9%. Again, it was just a matter of rounding. Towards the end, it essentially is 100%. Here we have aluminum nitrate. The formula weight is 213. We look at the percent aluminum. We have 1 aluminum atom. We times it by the atomic mass of aluminum, which is 26.98, divided by the formula weight times 100. Get 12.7. We have 3 nitrogens and 9 oxygens. We times those by the atomic mass units and divide it by the formula weight, and we get 19.7 and 67.6 respectively. Again, those add up to 100%. Finally, we'll look at ammonium nitrate. The formula weight of ammonium nitrate is 80.04. We have 4 hydrogens, 2 nitrogens, 3 oxygens. We times those by the respective atomic mass units and divide them by the formula weight of 80.04 times 100. And we end up with 5% for hydrogen, 35.1% for nitrogen, and 60% for oxygen. Again, you total those up and you end up with 100.1%. Again, it's not exactly 100 due to rounding. And there is 5 examples of how to calculate percent composition. It's not too hard, pretty easy. Thank you.